A lot of people think that because I can see that point over there, I have clear line of sight. That's not always the case. I deal with a lot of calls, and a lot of people, they try to put links together and say, well, I can see the other side. But what they're not taking into account is the Fresnel zone. So if we have an obstruction, do this here, sorry. So if we have a mountain, okay, now when I'm standing up here, I can see the other side. So I'm thinking, well, I have clear line of sight, but the Fresnel zone to this link and the way that the path actually comes across is here. It's more like an elliptical path. So this is your actual signal coming across, and what's happening is that the signal is actually hitting in here, and you're getting, you know, refraction coming off of this. And so when these packets are coming across, they're arriving at this antenna at the same time, or at different times, and therefore it's causing multipath, and you're going to get a degradation in performance. It's going to result in slower speeds, lower signal, and overall link performance will go down quite a bit. So the biggest takeaway here is that just because you think you have line of sight or you can see the other side is not always necessarily true. So in this case, one of the things you can do is you can actually raise your antenna, and now you're going to get over that, and you're not going to have Fresnel zone. You may have to raise both ends.
Is this effect more pronounced at the higher frequency, like 5.8?
Yes. So 5.8 is, so if this would be like a 900 megahertz signal, and a 5.8 would be like this. So you may actually be able to get a 5.8 signal to go into this on this link, and it would bypass this mountain because the Fresnel zone is a lot thinner. As you go into the lower frequencies, your Fresnel zone expands even greater. So 900 megahertz, you can bet it's probably going to hit that.
If it is like a steel fence or a wooden fence, stuff like that, would that be affected by the Fresnel?
Sure.
Okay.
If it's in the way. So anything that would cause the packet to hit it and then change direction. And even sometimes when you're doing like you may not even think of this, some people don't think of this, but if you're on a building, can't draw, if you're on a building, and sometimes they have a parapet here, and you install a link, having this right here is sometimes, it's right in the Fresnel zone. You're actually going to get a worse signal. So if you move your antenna closer to where this is not a factor, and take it out. So even the roof can actually be a part in your Fresnel zone. So you need to make sure that your links are high enough or your radios are high enough in your antennas to get over that.
Yeah, the other thing to know, like if you look at this diagram here, this one kind of shows it as well.
No.
Most of the path calcs do the Fresnel zone on your vertical, so how high above the ground you need to be, have Fresnel zone flare clearance. This kind of shows it that even if you have, like you've got, like you can see Matt, right? But let's say there's a tree right here, right? And it's off to the side. Fresnel zone actually it's like this. It's not just vertical. Mm-hmm. So just because you see it, like let's say there's a building over on the left, halfway between the link, but you can still see the other side, that could be Fresnel zone, that can create an issue as well. So it's not just below, it can be on either side of it as well. And that's really hard to see when you're doing a path calc. The only way you can tell that is if you get in, like look at a GPS, or look at a satellite image, and see if there's tall buildings on either side. That's the only way you can really tell, without going out and physically looking. So that's what they're showing here. They're also showing that you can end up with reflected signal. So whether it's a building or a tree, right? So you want to go on a reflected signal.
Yeah, well I kind of mentioned it before, but basically when it does hit something, that packet again is going to arrive at a different time than if it were to go directly to the antenna. And when you have reflected signal, you're going to reduce your received signal, and therefore a degradation of the entire link.